Hello guys, in this lesson we will look at the fields and solvers in Maya 2017. So first of all, I will go to FX tab and then I will go to nParticles and then create just simple emitter. So I will go to the option box and then edit, reset the settings and click create. And then I will go to the time slider settings. Let me expand the window a little bit. Here you see Maya changed some settings in this version. I am using version 2017. So you may see a little bit difference in the previous versions and this version. So just set the max play back speed to 24 frames per second. So now I will click save. Now if I hit play, now we have the real-time animation. So as you see the particles falling down, the reason is the nucleus tab. If you go to nucleus tab, you see here we have the gravity 9.8. So I will set it to 0. And now if I hit play, you see the particles going in all directions. So I will select the particles and then I will go to fields and solvers. And then let me just cut off the window and put it somewhere here so we can see it. So now if I click on air, of course my particles are selected, air. And now you see here we have in the predefined settings we have wind. Now if I hit play, as you see the particles moving upward. The reason the particles moving upward because we have the direction set to 1 and the magnitude controlling the force on the particles. So for example, if I set it to 20, now you see the particles moving very fast. So let me set it to 5. The attenuation is 1. So what that mean? 1 means that the force, the magnitude is 5 at the center here and slowly decreases over the distance. So if for example, if I set it to 0, now the air field is 1 in all the scene. Okay, so it's 1, the magnitude is 5 here, 5 here, and 5 and 5 everywhere. But if you set it to 1, that means the magnitude is 5 here, for example, and 3 here, and 2 and 1, and so on. So that's what attenuation means. And let me set it to 0. As you know, here we have x, y, and z. If you set the direction on x to 1, the particles will move on x. So let me show you. Okay, we have play. Okay, you see the particles moving on x direction. And now if I set the enable spread, you will see the particles will spread more. So if I hit play again, you see the particles spreading much more on x. So you can experience with these settings and see what every attribute does. So let me delete the air field now and let's see another force. So we have the drag force. So if I select the N particle and click on drag and I click play, we don't see any changes now. So if I select I will select the drag field and set it to, for example, 0.5 and click play. You see the particles is slowing more as it emits. So let me set it to 5, for example. You will see the particles not moving, stops after few seconds. So the more you increase the magnitude, the more the particles will lose their energy. So that's it for the magnitude. And the attenuation, of course, as I said, that means on 1 means that the magnitude is 1 here because I set it to 1. For example, if I set it to 2 and the magnitude to 1, that means the magnitude is 2 at the center and decreases as we move by distance from the center. Okay, and the speed attenuation, how much you want to drag field to increase or decrease. So for example, here you see, as I increase the speed attenuation, you see the particles moving more from the center and then stops. If you set it to 0, you see the particles stops in this area, and when you increase it, the particles moving much more far from the center. So that's it for the drag force. So let me delete the drag force, and then let's select the gravity. Of course, the gravity you can select the gravity from here, or you can just go to nucleus and set it to 9.8. So let's see. In the nucleus we have 0. Okay, so I will go to n particles, select the n particles, and then click on gravity field. So now the particles will fall down. Okay, as you see, the direction is -1 and the attenuation is 0, which means the gravity is 9.8 in all the scene. But if you set it to 1, for example, now you will see the gravity is slowing, is strong at the center and decreases over the distance. So that's it for the gravity field. So let me delete the gravity field and select the n particles. And now let's go to Newton field. I select the Newton field and click play, as you see the particles moving outside and going to the inside. So let me move the Newton field to the right a little bit, and now if I hit play, you see the particles attracting to the Newton field. Of course, the more you increase the value of the magnitude, the more the particles will attract much more faster. And the attenuation, as I said, now the Newton field is 10 here and decreases over the distance. Okay, so if I set it to, for example, 0, and now the Newton field is 10 in all the scene, no matter how far you place the Newton field. For example, if I placed it somewhere here, you will see the particles will attract to the Newton field. But if you set it to 1, for example, the Newton field is not 10 here. So if I click play, you see the particles not moving, moving slower. If you set it, for example, to 5, the particle will not move. So that's it for the Newton field. So let me select the Newton field and delete it. So let's go to the turbulence field. I will click for the radial field. So I will click on the radial field, and then let's hit play and see what's happening. The radial field pushes the particles outwards in all directions. Okay. The magnitude is 5, attenuation is 1. The radial type you can experience and practice and see what that doing. Okay. So for example, let's try 10. Actually, you cannot set it to 10. Let's try 0. Let's try 1 and see the difference. Actually, I don't see much more difference between 1 and 0. Okay, we have the distance, use the max distance and so for example, if you hit play and set the max distance, and to 0 and fall off, set the fall off. Now you see the particles pushing the radial field, pushing the particles and then slowing down. So that's what the max distance do. Of course it's 0. If you increase it, as you see now, the particles moving much more far away. So that's it for the of course you have here the volume control attribute. We have none, so you can set it to sphere and you can scale it. Now the particles will move outside the sphere. Okay, so if I uncheck the max distance, now you see we have here the attenuation 1, which means the magnitude is 5 at the center and it's 0 in this area. So you can experience with these attributes and see what each attribute does. And so let me delete the radial field and select the end particles again, and let's go to turbulence field. Turbulence field, if you click play, you see we have some turbulence and noise on the particles. So let me set the frequency to 5 and you will see the particles will move faster and much more noisy. Okay. And here you have the noise level. You can increase the noise and experience which what every attribute does in the phases Y and Z. As you see, I am changing the direction of the placement of the noise in the scene by changing the phase. Okay. Of course, here you have again volume control, so you can set it to a sphere and let the particles just have the effect of noise in the sphere. So the turbulence field will have no effect outside the sphere. Okay. So let me now move the sphere just a little bit, and you see here now the particles will have the effect of the noise when they enter the volume. Of course, you can change it to cone or torus and what you like. Let me delete the turbulence field. Let's set the nucleus, select the end particles, and let's click on the uniform. Uniform force is similar to gravity. So as you see, we have 5, 1 and direction x, which means the particles will move on x. If you go to volume and set to cube and then move the cube a little bit to the right and then play, you see the particles when enters the cube will have the magnitude of 5 and then they will move on x. Let me delete the uniform field and end particles, again selecting end particles, and then we have the vortex field. Now you will see what vortex field do. So I will increase it to, for example, 5. You see we have the effect of rotating the particles at the center. You can of course add multiple forces, select it again and add drag force. Let's set the drag to 0.2 and then click play. Actually, I will increase it to 1. And now you see the particles will move slower. Let me select the vortex field. And let's set the volume to a sphere. And let's increase the sphere. Now the particles will have the effect of the vortex field just in the sphere area. Okay, you can of course, you see here we have tap inside. If you select it, the particles will remain inside the volume and will not go outside the volume. And tab radius, how much you want the particles be in the volume. Okay, as you see, 0 will move the particles outside the volume, and you have there the axial magnitude. You can experience with these attributes. So let's delete the vortex and drag force and select the n particles again, and let's add volume axis. So what volume axis does? So if I hit play, you see the push again pushes the particles outside. Of course, you can set the away from center, for example, to 10. That will push the particles away from the emitter. You have here along the axis, if you set it to 1, for example, you see here we have a little arrow here, dotted arrow. So which means that the particles will move in this area. So if I set it to 1, and you will see the particles moving upward because the along axis is 1. Around the axis, we rotate the particle around the axis. For example, set it to 1, and then you will see the particles will rotate. Just set it to 10, for example, here. I will hit play. As you see, the particles now rotating around the center. And here you have the turbulence. You have the turbulence speed, how much speed the turbulence will be, and frequency, and so on. You have the distance, and the max distance controls the distance that the volume axis will control the particles, and so on. So let's look at another force, which is the volume curve. So if I click on volume curve, you see here we have curve which with circles. So now if I hit play, you see the particles will move along the curve. So if I move the curve here and then click play, you see the particles that enters the circles will move along the curve. Of course, you can increase the force of the curve, and of course again you can select the curve and right click and choose control vertices and then control the curve shape. So now the particles will move along the curve. Okay, you see the particles moving along the curve. So you need to select the first vertex and move it. As you see, the particles now moving along the curve. You see here the particles going outside. The reason is you go to volume axis field, and then you go to magnitude and set it, for example, to 60. And then click play. You see the particles moving much more faster, but going outside the curve. So you can control that by adding a drag field to 0.5. Let's see now. Again, we'll increase it to 3. Set the attenuation to 0, 2. I think we need to set it to 0.2. Let me decrease the magnitude to 20 and set the attenuation to 1. You can experience with these values until you see the curve, the particles going outside. You need to change some attributes here. Okay. So that's how the volume axis field works. So I hope you enjoyed. I will see you later.